the internet today is basically has two main features. One, it is infinitely scalable. The more people want to launch websites, web applications, this that, they can launch their own website servers and everything. Second, it's seamless. Like, you are sitting somewhere else in the world, I am sitting somewhere else in the world, we can create, consume, share information freely. We don't have to like download from one information, which used to be the case back in the day, 40,
Yes.
50 years back, when there was DARPANET and Euronet and all that. All these networks were separate. Now, what Polygon 2.0 tries to do is exactly the same, but for value.
Oh yes, guys, we're back with yet another legendary interview. And if you've been watching us since 2017, 2018, you know that we kind of invented this genre of interviewing legendary crypto founders. And today with us, we have Sandeep from Polygon. And he's going to speak about the future of crypto, because Polygon 2.0, which is the main topic of this episode, is all about how we're going from developers building apps on top of ETH, on top of Polygon, on top of other specific blockchains, to now developers creating app chains. And this app chain paradigm is going to be very, very strong. Before we get started, a quick word from our sponsor, which is ourselves. We at Morales.io are the leading Web3 infra provider. We're powering MetaMask, Blockchain.com, and other dApps that are serving millions of users each and every day. In fact, if you are a Web3 user, you are most likely using a Morales-powered app each and every day, because we are the backbone of this industry, and we are the go-to solution for all developers who want to build and be successful in this industry. So if you are a Web3 developer, you want to get started as a Web3 developer, go to Morales.io and sign up by clicking this button right here. Right, guys, welcome back. As you can see, we have a very special guest with us today. We have Sandeep, one of the founders of Polygon, and today we'll be discussing Polygon 2.0, because these guys have been shipping like maniacs, especially now in the bear market. I see almost every week there is something. There is some acquisition, there is some kind of ZK, some kind of Supernet. So there is a lot of stuff going on, and we really need to record this update for our community, guys, because last time we had Sandeep on, I think it was like 1-2 years ago, so a lot has changed. Sandeep, big welcome. Well, what's happening? What's happening?
Thanks for inviting me, Ivan. Yeah, I mean, a lot of building going on at Polygon. You know that we are here focused on the long term. Like our beginnings were like we started with the Binance IO and whatnot, but the goal has been very clear that we want to build the layer where business is built on top of Web3, and it takes Web3 mainstream. And since then, that we have been very focused on all of these things. Like, we launched in 2020, and after that, in the next 2 years, we became the most adopted blockchain, whether it's DeFi, whether it's NFTs, gaming, brands, like everywhere. Seems like a huge number of developers are building on Polygon, and by daily active users and a number of active addresses and all that, we continue to be the most adopted, the number one blockchain by many accounts, if you see. So, but then when Polygon started in 2020, at that point in time, no layer 2 technology was properly feasible, right? And then after that, optimistic rollups technology came in, which we didn't believe in, because it was still like a temporary solution. It was not like a full-blown solution. And then we started focusing on ZK, which we believe is the end game for Web3 scalability. And in 2021, as you know, that we spent almost like a Polygon ecosystem basically merged with the first Hermes, and then the Polygon Zero team, which was previously Mir protocol, which brought in and which made Polygon like arguably pound for pound one of the best teams in the ZK space, probably the best team, but definitely one of the top 2 teams. Only other team I would say is like comes close to Starkware, which can compare with that level of ZK expertise with Polygon.
And
since
Sandeep,
then,
Just some context. So our community is very well familiarized with the project, and many people have had insane performance in Matic. In Matic as a coin, it's been a fantastic ride, and I think many people know the version 1 of Polygon. But now with all of the new things you guys have coming, it's important that we really explain everything, which you did partially. But let's start with the basic. Why do we need to move forward from Polygon proof of stake, which is what most people are familiar with and have used, and where most devs probably are right now? Well, why did you feel this need to outgrow it and grow further?
Yeah. So Polygon, as I said, that when we launched in 2020, there was no proper layer 2 technology. What is the meaning of layer 2 technology? Meaning of layer 2 technology is that you need to be able to have the security of Ethereum. Even though you are on a different chain, you want to have the security of Ethereum. So previously, Polygon POS chain has its own security. It was very strongly connected to Ethereum, but it was not secured by Ethereum. And all these layer 2 technologies, whether it's optimistic rollup, ZK rollup, these are all technologies to secure your chains, layer 2 chains with Ethereum. So that's why we need to move like this Polygon 2.0, but we are calling it Polygon 2.0. It has multiple stages to it. One of the stage, and the first stage is Polygon POS chain converting into a ZK chain, so that this Polygon POS chain, which is the most adopted chain, this is secured by Ethereum. So currently the chain has like $2-3 billion shipped to bridge to Polygon POS. But once it's secured by Polygon ZK, ZK technology, and is secured by Ethereum, then people can bring in even more, like billions and billions of dollars, tens of billions of dollars into that chain, because then now they know that the security of the chain is fully ensured by Ethereum using the ZK technology.
Yeah. So right now you stake Matic, and then you can be a validator in the network. Like that's the original approach. And all of the consensus happens outside of Ethereum. It is on Matic network with the validator. So now with ZK is going to be a layer 2. And the whole idea with ZK is that computation happens on layer 2, but then it's put back on layer 1 as it settles back on layer 1, and it's cryptographically proven. And how will that change practically for, let's say, validator? Someone who is running today a validator with Matic, how do they transition into this new paradigm?
Nothing changes for them. So anybody who's running a validator, they will just need to upgrade the new system. So it will still have Matic validators who are running like 100. It's decentralization. But then you also have provers. Everybody will be also running a prover. And when they are creating a block, they will just create a proof and put it back on Ethereum. So it will be the world's first decentralized layer 2. Right now, when we think of layer 2s, the biggest problem is we all think of these, like let's say OP chain or Arbitrum and even Polygon ZK EVM. These are single sequencer, but that's not the end state of these chains. This is just the starting stage of all the layer 2s.
Yes.
All layer 2s eventually need to decentralize. If you don't decentralize, then that layer 2 is basically a kind of running an exchange or something, right? Which is not, regulatory wise also, and not feasible for DeFi also. Because let's say for these single sequencer rollups, right? Let's say you are on today, like Arbitrum, for example, is very big in DeFi right now. And let's say you have a like high volatility situation, and there is liquidation going to happen for something, right? Like that recently, what happened with Curve and all that. But then if you are on Arbitrum, and if it's a single sequencer, even though like right now it's a trusted setup, we know that Arbitrum team is good, then they will not do anything. But if somebody else is running that single sequencer, they can simply censor all the liquidation transactions, right? So it's not the end state. You need to have decentralization on layer 2 for all the networks. Like it includes Arbitrum, Polygon, the OP chains, any other layer 2s who are going to launch. They will start as single sequencer, but they have to grow into the multi-sequencer, which is the validator layer. And that's when we upgrade the Polygon POS chain with ZK. So ZK will be plugged on top of it. So the chain will still remain the same. Everybody will stake their Matic. They will earn the transaction fees and all that. But you plug a ZK prover and then also add ZK prover. So there is an added security on that chain.
It's interesting what you said, that what is the difference if you have a single sequencer and you have an EVM running and you're the only person validating all transactions and putting them on ETH? What is the difference between that and centralized exchange? Is it just that it's EVM interface to run transactions? Because the difference does become very blurry, and I agree with you that it's either you decentralize yourself or you are a massive target for regulation. So it's very important that the industry moves in this direction. But basically, let me summarize how I understood it, that the Matic, the Polygon network, it is the same, but now all the validators, they have an additional task, and that's that they need to put, using ZK technology, the state onto ETH. In this very simple upgrade, they upgrade the software, and now their software, instead of just validating the transactions on the Polygon, now it's also putting the state on ETH. And this way, because you guys are decentralizing in this fashion, that no one can censor. And like these validators, is a decentralized network, so no one can censor, like what you said, for example, this liquidation transactions. Or maybe if there is, like we saw with Coinbase Layer 2, this scam going on, $100 million scam with Bold, they could, in theory, if they have centralized, I'm not sure exactly how they are set up, but it's another question I've seen raised on Twitter. Like, could Coinbase be liable if they have a centralized sequencer that they don't stop the scam, for example? So yeah, very relevant in this time. And in terms of roadmap, how do you guys view this? Let's say that I am a validator on Polygon right now. When do I start doing this ZK validation?
Yeah. So right now, what we have said is that we have put in a proposal, and it will go for the community vote while the technology is being built out. Once the community approves that yes, let's move to a ZK rollup, then, and the technology is ready in next 3 to 6 months, then we will put forward this upgrade. Community will audit and everything, and then everybody can see. And once the community votes that okay, let's move, then all the validator, there will be a cutoff date where all the validator will update their software and start using the.
But are we speaking in terms of months, quarters, a year? When do you think is going to be approximately?
Definitely, we are talking about 3 to 6 months maximum, because we have already figured out all the technology and everything. It's more of a migration. Basically, not many people realize that this will be as big as Ethereum merge, because when Ethereum had this huge chain and then it merged from proof of work to proof of stake, it is as big as that effort. So it is going to take time, but I think we will line up the update in next three months roughly, and it will take 2-3 months of time with various cutoff dates and all that. But the main idea is that no validator and no user needs to do anything. They will not even know. Just like on Ethereum, when Ethereum from proof of stake to proof of work to proof of stake, no user, nobody knew, right? Like exactly. So that's the goal. For the users, they don't need to do anything. Validators, they just need to upgrade their nodes and everything should be fine.
And Sandeep, one of the questions I've seen being raised over and over again on Twitter, and also people in our community are asking about the bridge and the multisig, and that Polygon has this multisig. Personally, I don't know the details, but will this solve it? Like, will this put this debate at rest with Polygon 2.0? Maybe you can give some context, like what is this thing about, and how will this upgrade solve it?
Yeah, that's the whole point. Like, instead of you relying on this checkpoint mechanism, you will rely on a ZK proof mechanism. Secondly, the multisig, for example, that multisig is a security upgrade, like security committee, and every layer 2 has it. Every layer 2, Arbitrum, Optimism, ZK Sync, anybody.
Yeah, but we have to move away from that, right? We need to move away from this paradigm, right?
Yes. So that's why what you do in these multisigs now is like these are security upgrade mechanisms. What you do is there is always as per Vitalik's kind of some of the guidelines he also put in, there needs to be a minimum 10 to 30 day delay period. So with the multisig, you can't take the funds. Like multisig is not like where somebody can take the fund. No, with multisig you can upgrade the smart contracts, right? So when you put an upgrade on the smart contract, there is a 10 to 30 day time lock. And you broadcast it to the community that, guys, this particular upgrade is happening. If you don't agree with it, you think that your funds will be at the risk with this upgrade, you simply don't. You simply withdraw your funds, right? So that is how these all the layer 2s are dealing with it. But as you said, eventually, like after 2-3 years, when this technology is ready, imagine these layer twos have like Polygon itself has $3-4 billion. Some other layer twos also have multiple $1 billion. Imagine there is a security bug, just like Curve Finance, the bug was, right? And there is no upgradation mechanism also. Everybody loses money. Is that the right mechanism? Or you have a security council which actually is reviewing, which is governed by the governance selects who is the security council, who are the people. And then if at all there is a security incident, then you have the ability to upgrade it, because it will take some time to bake in, like all these layer 2 mechanisms, they will take some time to bake in. Like for example, Polygon POS, I think now we are in a stage where simply we can delete we can burn the upgradation mechanism, multisig,
because
and
it's in
say
your
that
it's in your best interest to remove it, right? Because you remove a bunch of like regulatory attack. If you have no control, you have no control. So it is in your interest as soon as possible to remove it. But because it's new tech, it is commonplace to still have this upgrade mechanism, and the whole industry is basically working to remove it. Is there any chain that has removed it in the layer 2 space yet that you know of?
Absolutely not. Absolutely not. No chain has it, and I don't think anybody will be able to fully do it before next 2, 3, 4 years, because you need enough amount of hackers trying to hack it and all that, because it's just irresponsible. Like let's say, imagine in 2020 we said that we have burned the multisig, no multisig, and then users push their money, and after 1 year there is a hack and people lose $1 billion. Like, are we will be safe? We'll say, guys, we don't have any regulatory this thing, but is it responsible for the users? Like, you have to choose between what is responsible for the users.
Yeah, I know super difficult choice. Absolutely.
Yeah, super difficult choice, because many retail people will say, oh, you have a multisig and all that, but then you ask it like, would you rather prefer losing all your life savings if there is a hack, or what's this? So it's a difficult choice, but I think now the whole layer 2 industry has come to a place. Now there are enough mechanisms where anytime you are upgrading, there is a time lock, and there is a community defined security council, which everybody knows that, okay, this security council is there. In case of a immediate or urgent attack, they will be able to upgrade a few things. But yeah.
And in terms of the ZK EVM, so you guys are gonna upgrade your system to ZK EVM. There is also all kinds of other ZK EVMs with ZK Sync, and even I think if I'm not correct, all of these optimistic ones, they're also kind of looking at ZK, at least in the roadmap from what I saw. But how do you view the differences? Because in my understanding, there are some differences in terms of EVM compatibility, different trade-offs. Maybe you can speak about that. Like, how does the landscape look like of ZK EVMs, and what are the differences, and what path have you guys chosen in all of these different trade-offs?
Yeah. I mean, see, that's what, like, if you discuss with any researcher worth his salt in the space, they will tell you that Polygon is the #1 team in the ZK EVM space. We launched our testnet, the first one, and there is nobody else who has a ZK EVM fully in production, fully audited, mature, and everything. ZK Sync has it, but they launched the mainnet without even the audit and everything, because it's such a complex technology. So, and then they did audit along the way, but these are also not audited with the I'm not sure like whether any proper ZK company or ZK auditor has audited them and all that. These are fairly immature systems. Polygon ZK EVM, the ZK part, the ZK proving and chain security and all that wise, we are the leading blockchain in the space. Plus, we also have put in, while building our ZK EVM, we built a lot of like software which is basically being used by many other people also. Like, for example, Pill, which now even Ethereum Foundation is looking at, that it's polynomial in language, polynomial writing language, and so a lot of it has a lot of kind of attention from the researchers. Then our Plonky 2 is considered to be the fastest ZK proving library or the system which everybody is using these days, and that is also built by Polygon. And recently you would have seen that whole issue that
I have seen a bit of spicy drama.
Because if you go deeper into that, you'll realize that some of the competitors, like ZK space people, they are like, because that is like so supreme, that the most important performance part they completely copy pasted even, and the other part like changing few things they developed that and all that, but which tells you it's open source. All we requested is basically there should be enough attribution. For example, for the performance, there is this thing called Goldilocks field, right, which our team, Himesh from our team, invented. And then from some of the people from this particular team particularly, they tried to obfuscate the language and saying that this is some other Goldilocks thing which has nothing to do with this. So all those kind of things were problematic. But point being that this all tells you that Polygon ZK technology is like so far ahead of everyone else that
But
people,
is it? But in what way is ZK compatible with EVM? Like, is it 100% compatible? Because from what I heard, like, there's always like something that is not 100%. So, but has it developed since that? Is it like 100% compatible?
Yeah. So in our case, our ZK EVM is, I think, 99% compatible. When I say 99, I'll tell you the meaning of that. So if you go to Ethereum, and 99% of the smart contracts, you can scan the blockchain, right? 99% of all the smart contracts and 100% of all the massively used smart contracts, they are 100% compatible. There are one or two rare features which nobody uses, like pairings. Very few people use pairings, and one or two opcodes which are not there. But we are also, like, by December they are also being added. So pairings is being added. A few opcodes are also being added, which nobody uses, but just for the sake of, because in our industry it's all the narrative. Like, see, you heard about something, like, because somebody wanted to FUD us, they just say that, Polygon ZKVM, it's not 100% compatible.
It wasn't to FUD you. It's in general. Like, I mean, we who work in tech, we know that there's always some trade-off, and especially with new tech, there is always some trade. So it's just in general that at least like 6-8 months ago, it was a lot like, this team is prioritizing that and this and that trade-off. So it's from that perspective. But it's good to hear that you guys that the technology has come so far that most smart contracts work already, and until the end of the year is gonna be all of them.
I have not found even a single developer. So many people have deployed their smart contracts on Polygon, and multiple people have actually said in public also that this is the most smoothest experience for them, because they just have to copy the code and deploy. And I have not seen even a single. And you will also, you also do a lot of hackathons and all that. I don't think you will ever find a developer who will say that, this is not working, because those 2-3 opcodes are very kind of extreme opcodes. Nobody uses them. Even on Ethereum, nobody uses them. So that's why.
Makes sense. So next, let's speak about the ecosystem that you guys are building with the Supernets. I also know a lot of projects are coming online. I just met GameSwift team in Paris, and they're building a gaming ecosystem. And also, you guys work a lot with Immutable X together and building. Before we do that, let me give a big shout out to actually ourselves in terms of sponsors, because this episode is sponsored by ourselves, and that's always the best when we can episode and sponsor ourselves. So go, if you are a dev, what you have to do right now is to go to Moralis.io. We do support Polygon. We support Polygon, by the way, from day one in all our APIs, whether it is an NFT API, token API, wallet API, whether you're building Block Explorer or wallet, portfolio app, game, Moralis.io is the place to build. Used by MetaMask, blockchain.com, Delta Wallet, all kinds of projects, tier 1 projects are building on Moralis. So if you are a developer looking to build, by the way, which you should do as it is the bear market and you should prepare for the bull market, go to Moralis.io, start as soon as possible, and we will be supporting all kinds of Polygon innovations as they become available. On that note, let's continue with our agenda. Next on the agenda for us is the Supernets. Can you, Sandeep, speak a bit about what it is, what it means for us, for example, in terms of infra, and for users? How do you envision this future?
Yes. So first, let me give you a background of Polygon 2.0. What is Polygon 2.0, right? So basically, we did this, like Polygon POS, as we discussed, that it was a side chain. Now it is becoming ZK Rollup. Then we have Polygon ZK EVM, which is Polygon Hermes. And then we have Polygon Zero, which is building a type 1 prover. Let's not get into that. It's like an even more complicated topic. Like that is 100% compatible with EVM. This one, type 2, right now that we have live is 99%, 99.5% will be compatible. But type 1 is basically 100% compatible. Then we have Polygon Maiden, which is actually building a ZK rollup, which can actually create different, which will allow you to use different languages, right? Like for example, Rust and Golang and all that to be used on top of Ethereum on the layer 2. So Polygon 2.0 is basically consolidation of all these efforts from our side. And now you will see Polygon 2.0, it will be basically, basically an ecosystem which has one or two public chains. Let's say like the Polygon POS and ZK EVM, these are the public chains. And apart from that, there will be hundreds and hundreds or thousands of app chains, right? Like which are called super chains, Supernets, basically. All of these are app chains. And then there is an aggregator layer which will, all these Supernets will be only ZK proven now, right? So Ivan, you are on the Maiden page, so maybe go to the Polygon 2.0 page, which is
let's see, is it solution? Let me go to Polygon.
Yeah, this home page, like
okay,
where you see the announcing Polygon 2.0 at the top, you see, right? So this one, yes, and this value layer of it. Yeah. I think you clicked it. Yes, this is the main part. This particular link is the main link where you are currently. If you can scroll down, I will also show. Yes. So basically you will see that the value layer of internet is nothing but these hundreds of chains. So if you see what is internet today, right? Like let me take like 1 minute to explain this, and this is the most important part that I'm going to say. That if you see internet today, this is Web 2. The internet today is basically has two main features. One, it is infinitely scalable. The more people want to launch websites, web applications, that they can launch, their own website servers and everything. Second, it's seamless. Like you are sitting somewhere else in the world, I am sitting somewhere else in the world. We can create, consume, share information freely. We don't have to like download from one information, which used to be the case back in the day, 50 years back, when there was DARPANet and Euronet and all that. All these networks were separate, but then they got connected. That's why it's called internet. So two of these features: infinite scalability and then seamless connectivity or seamless movement of information. Now, what Polygon 2.0 tries to do is exactly the same, but for value. So today, no matter what blockchain you have, every blockchain has a capacity limit, right? Because what you are doing is there is a single state machine or single database, which we call ledger. Blockchain is a ledger, right? And all transactions are trying to upgrade that particular ledger. So this always have limits of how much you want to, how much you can, transactions you can put in over there. And that's why everybody wants to scale and all that. But with this app chain scenario, what you can do is now you can have hundreds or thousands or tens of hundreds of thousands, chains basically, no matter how many. So it's infinitely scalable. Today, any chain, Morales wants to launch their own chain, they can launch their own chain. Any app, like for example, what happens with most of these big games, they launch on, let's say, Ethereum or Polygon and all that. Once their game starts exploding, the gas fee starts going really, really high, right? Yes. But instead of that, they can have dedicated capacity for their own chain, right? And then have their token. Their token is the gas fees and whatnot, whatever they want to do with that. So you can have hundreds and hundreds of these chains. So infinite scalability. You can have thousands, infinite number of chains. So first part, infinite scalability. But what happens is when you have all these different chains, then there is no seamless interconnectivity between them. Then you have to use bridges. And we have seen so many bridges which got hacked, like multi-chain recently was the bridge which got hacked and all that, right? So you have to trust somebody else to move the value. But with Polygon 2.0, all these chains are there. And then below that, you have an aggregator layer. If you click on this Polygon 2.0 value, the first link, can you click on the first link here? Yes. Click on this read block. Can you click on there is a read block button. Yes. Click here and go down. You will see a particular image. Okay, no, not this one. Basically, can you go back? Let's go to that particular image, because the image, go back.
Oops, sorry. Share this tab, go back.
Yes.
Maybe
maybe the The third one, yes, architecture, yes, protocol architecture.
Let me check.
Click on this probably, yes, and then go down or more. This is the stack, but go down. This particular image, yes. If you can click on that image and maybe if you see that on top of the image there are multiple chains like ZK EVM is there, Polygon P is there, Supernets are there, right? Supernet chains are there, and there can be any number of chains. All those chains, as I said, infinite scalability, but it's very hard to move value between them. You have to rely on some bridge. But then now, because of the power of ZK, you have this interop layer that we say aggregator layer or interoperable layer. What happens is all these chains now publish a ZK proof onto this aggregator layer, and that aggregator layer combines their ZK proof and puts one single proof on Ethereum. What happens with that is, let's say you are chain number S1 and you want to go into ZK EVM some value. You are playing a game on chain number S1 in this image, and you want to move to ZK EVM and convert that game tokens into USDT. So right now, how you can do today, you will have to use some sort of trusted bridge, and if the bridge gets hacked, everybody's screwed. But in this case, the chain S1 is also putting a ZK proof on interoperable layer, right? And ZK EVM can see that chain S1 has proved on ZK EVM. The moment S1 has the ZK EVM sees that S1 chain has proven on the aggregator layer, then it can allow any transaction that is coming from the previous proof, right? Any transaction, so you can just
and
prove.
Sandeep,
Yeah.
One question about the proofs. By the way, let's first recap what you said, because it's important with this horizontal scaling, because no matter how much you scale one chain, like people are saying, let's scale ETH, 10x, or some people are saying we have a chain which is 10x transaction, 100x transaction, then ETH is always going to get filled up, because there's always use cases. You can let loose arbitrage bots that are going to be trading like cents in profit if you decrease the fees. So there's always going to be flooding of transactions, no matter how big the chain is. So it makes sense to have this split up of chains. And how does the size of the proof relate to the number of chains you have? Let's say you have 1 million chains. It is still the same capacity on ETH. Is the size of the proof the same no matter how many chains? Maybe speak it, because I think that's the first thing people will think about. Many chains, it's still gonna be settled on one ETH. How does that work?
Yes. This is exactly, you hit just right on the nail, that on ZK, no matter how many transactions you have, you can actually you can just scale up your provers. Let's say if there is a chain which starts doing 1 million transactions a second, right? Or 1 million transactions every 5 minutes. You can just scale up the provers, prove all the chains, prove all the transactions, and still have the same amount of small proof, which is the same size, right? And now you have 1 million chains, and 1 million chains are putting the proof on the intermediate layer. And then you can just combine them, and then it still becomes one single proof. So essentially 1 million, like if this interoperable layer was not there, then what you would do, all chains will have to put on Ethereum, right? And everybody will need to pay for that 350K gas, like $50 to $100. But instead of that, when you're putting on interop layer, you can prove faster. And once you prove, your proofs are combined, and one proof is being put on Ethereum. So all chain combined are giving $50 instead of one chain, every chain giving $50, and Ethereum getting congested. So that's
how often do you put stuff on ETH? Like, what is the trust window? Because there's going to be some trust window where let's say I play a game and they're super quick, millisecond block time or whatever, it's super quick, but then it gets rolled up to the interop layer, and then from there it gets rolled to the ETH. So what can you speak about that, like trust window, where I'm not trusting ETH yet, where I'm not secured by ETH yet? How will that work?
Yes. So that's the most fun part, like, because now you can prove every 10 seconds, because you don't have to put on Ethereum every 10 seconds, which is super costly. So instead of that, you prove every 10 seconds or even 2 seconds. Every 2 seconds, you are creating a proof and putting on interoperable layer, right? The moment you put on interoperable layer, all the other chains can see a ZK proof. They don't have to rely on your security. That is why this is so powerful. Even that trust window that you are talking about, even within that trust window, there is a ZK proof. And then once a chain submits a ZK proof, there is no way you can't fudge a ZK proof. So basically, there is no way.
This ZK, so ETH is really used like a storage solution, or right? Because if you say that it's all, as soon as I have the proof, it is in. Settlement. Yeah.
Settlement. You can say settlement that ETH, basically you have, let's say 1 million chains, all or 1,000 chains, like million is too much, like 1,000 chains. All of these chains, whatever they are doing, every, let's say 10 minutes, you are putting all the proofs together and putting it on Ethereum. But even within those 10 minutes, you are having ZK proofs which are going on interoperability layer every 2 seconds.
Yeah,
so
because at the end of the day, even if a thing is not on ETH yet, and I have the proof, it's not on ETH, it is it's being collected, it's being like aggregated in the interop layer. If I have it, I can always include it myself later on, so I don't have to trust this interop layer necessarily. So from that perspective, from that perspective, ETH is more like, it's settlement / like storage, like it's stored forever. Once it is on ETH, it's confirmed, it's stored forever. But in the technical term, you call it settlement. And in terms of, I know also in these circles of ZK, people are speaking about data availability. So what is that? Is that, which layer takes care of that? Isn't it ETH then, if it's stored on ETH?
Yeah. So basically, right now we only discuss about putting the proof. Data is a separate topic. Like data topic, for example, ZK EVM in this diagram, ZK EVM puts the data also on Ethereum, which is super costly. But then the data provides you. So there is one part. Like, see, you can have a chain where you don't provide the data on Ethereum and you still prove on Ethereum. Everybody knows that you are running the chain fine. But there is one attack vector that you can do. If you are a single rogue player, what you can say that I'm not showing you your data, because in order to exit to Ethereum, you need to have your data. You need to show your data that this is my data and this is I have $1 million on this chain and I want to exit, right? So for that data attack, like data ransom attack, there can be a possibility that the operator, the single operator, if you are a single operator, multi-chain, it's even smaller. But if you're a single operator, you can say, I'm not giving you your data. You have $1 million, give me 200K, then I will give you the data. So it's called ransom attack. That attack is possible technically, but although there are multiple things now, it's also getting super difficult. You have forced transactions and all that, which makes it super difficult to do that. But I am saying, still, like, for DeFi, for example, where you want to have tens of billions of dollars, there you want data also to be secured by Ethereum. So for example, Polygon ZK EVM, which is a DeFi chain, that puts all the data also back on Ethereum. Hence the cost per transaction.
But what is the data? So you have the sorry to interrupt. So you have the proof on ETH, but for that proof to be useful, right? You need the data. Like what do you need the data for if the proof is there?
Data means your transaction data, where you actually sign a transaction and say, I am transferring $500 to this actual data of the transaction. The proof already has that this transaction happened. But then when you want to go to Ethereum, you want to be able to prove, or you want to be able to show that I have this particular data. Like, this was my transaction. I burned 100K and now I'm withdrawing 100K.
Okay.
Right?
So proof is like a hash. It's like
proof is like a hash.
Proof is like a hash. So in itself, it's useless if you don't have some data that the hash proves, or in this case, like the ZK proof will prove your transaction history on layer 2. But if you don't have the transaction history, this proof is just random piece of information. Right?
Correct. Or only for exiting, you need this information when you want to exit some data from there, right? But this ZK proof is called validity proof, right? So on the smart contract, let's say your chain is putting a proof every 5 minutes, right? And the next proof, when they put the transaction fails, you know that there is some fraud has happened. So from the previous 5 minutes, from the previous checkpoint, everybody can exit. Only case as in case of data where the data is not stored on multiple machines, then the operator can try to withhold the data. When you say, I'm not showing your data, I can't steal your funds, but you also cannot take it out. In case of optimistic rollups, if a single operator wants to steal your funds, they can try to steal your fund. But in ZK, he can't steal the fund. All he can do is play a stalemate. That I'm not showing you the data and you can't take it out. Give me some sort of ransom. There's only one. But imagine that every operator, all you need is they need to be putting some data in either a data availability layer or into, let's say, IPFS. Once you are putting the data on IPFS, everybody has the data, right? Like IPFS, the storage. Like somewhere, if you are storing, it's fine. So it's a very, very small, for example, gaming, nobody will put their data back on Ethereum, right? Like, because you just need the proof where people know that the value is fully secured, they can't ban me and all that, but they can have a data in the off-chain store. You can dump it where it's much, much cheaper. That's where you need to use it. That's why these are two different settings. That's why these are two different settings of chains. One is a roll-up, like ZK EVM is a roll-up. Polygon POS ZK EVM, when the POS converts into ZK, will be a Validium. There are two things, roll-up and Validium. Roll-up means both ZK proof and data on Ethereum. Validium means only ZK proof, data is off-chain.
Makes sense. And in this environment, how will bridging work? Because you mentioned that traditionally bridges are an attack vector and they get hacked all the time. And how it normally, there are different ways to do a bridge, but one of the common ones is that you have some smart contract that holds original assets and then mints receipt assets on another chain. And with this ZK paradigm, it should be way more secure. So can you explain how that will work? Let's say I have some assets on S2, let's say Supernet 2, and I want to trade it on ZK EVM. What is the mechanism that is better in this case?
The fun part is that ZK proof is the bridge. So what you said is like, what is the bridge? Bridge has two smart contracts on both sides, and you have a trusted party who is saying that, okay, Ivan deposited $100,000 here and he's withdrawing $100,000. Either it's a trusted party or that trusted party is doing some sort of trusted calculation, like, or a consensus between 100 or 20 people who are doing a consensus, and then you are putting a proof that yes, this transaction happened. But when you have a ZK proof, you still have both the sides of the smart contracts, but then each side is publishing ZK proof from one side to another. There's no trusted action that is happening. As far as the ZK proof is there, the trust is maths. Right. So when the interoperable layer is putting in this case, S2 puts the ZK proof on the interoperable layer. When ZK EVM is processing the incoming transaction, cross-chain transaction, it simply refers to the interoperable layer. It says that, okay, this is the proof. Okay, this is the proof from S2. And now Ivan is showing me a transaction, which I can easily verify that it is a part of this hash or this ZK proof. Right? I can easily verify. The moment I see that it's better, then I know that, okay, you actually did that transaction. That's the fun.
So traditionally, the bridge is based on some central party that looks for, okay, here is the inserted coins I mint on the other chain, and here a burn transaction on the other chain. I give you back the inserted coins. But in this case, all of these operations will be governed purely by the ZK proofs, basically. That if you don't have a proof, it's you cannot unlock. Makes sense.
Yes. And exactly. So basically, the trust factor is maths. In this case, it's only mathematics. There's no cryptography. There's no this thing in between. Yeah, sorry, go ahead.
Yeah, and in terms of this shared services that all applications need, let's say, for example, oracles with Chainlink or something else that is needed cross-chain. For example, stablecoin or needed cross-chain. Well, bridges will take care of that. But in terms of big projects that all chains are begging to join them, like for example Chainlink is such a project. As soon as there's a new chain, they don't have an oracle, it's difficult for developers. How will you guys take care of this with this paradigm with thousands of chains? Can we somehow share, like if oracle is on one chain, it's also on all other chains? So how are you guys thinking about this?
I think that's a very interesting piece wherein I think people will be able to share the oracles also across the chains, where the oracle just puts the data on one chain and then every other chain can consume it using the ZK proof. It's just that there will be a latency part of it, right? Like if, let's say, the Chainlink is active on ZK EVM and ZK EVM is posting the proof every 5 seconds, then after 5 seconds, every other chain will be able to know that, okay, this Chainlink transaction, which has this particular data, is a part of this proof. So, okay, the value of ETH is right now this, for example, right? So all the chains will be able to use it. But like somebody will have to build that utility. But definitely that's the whole game. Like this whole ZK EVM, this whole Polygon 2.0 mechanism, the main purpose of this is that once we reach the place where every chain is putting the data or every chain is putting the proof every 5 seconds, like imagine the S2 puts a proof every 5 seconds and then ZK EVM picks up the S2 proof. So you were playing some game, you want to swap your game tokens to ZK EVM. You initiated a transaction, 5 seconds, the proof goes to interoperable layer, ZK EVM picks it up, swaps the transaction, in other 5 seconds puts the transaction, the proof back on interoperable layer, and S2 now can receive. So within 12 to 13 seconds, you have the swap done on some other chain, right? And it comes back to your own wallet. It's almost like Ethereum level composability, right? On Ethereum also, it takes you 15 seconds. So this whole thousands of chain, the whole point of this is this will feel like one single chain, one single big chain, just like you feel it on internet, right? Today you are creating some some
Exactly.
information and you are directly sharing with me. That's why we call it value layer of internet, right? Because it makes the value infinitely scalable, create as much value as you want to create, and share it and exchange it and all that across the network, seamlessly.
And I'm wondering, like, I love the vision that, you know, you come to blockchain and there's like everything seamless, all chains, everything. But then in practical reality, so for example, when we run our infra, such as for example Polygon, there is a lot of work to index everything, to cache all NFTs, to get the metadata moving, and so on and so forth. And let's say our clients, if they are to, because we work a lot with wallets, so how would a wallet onboard into this new reality where, you know, all their users can use all chains without switching RPC provider? Like, there are many things to solve here. One is, for example, the indexing of all chains that we work a lot with, and I guess there we just have to index as many of them as possible. And then on a wallet experience level, how do you guys see that? Let's say I download MetaMask, like how do I, because today I would still need to like jump to different RPCs and so on and so forth. How do you envision this future?
Yeah. So I think, like, all the wallets, eventually the big wallets, they will have to create a mechanism for all the developers of these chains, wherein, whenever you launch a new chain, they automatically, like, the developer already has the index. So I'll give you an example. So all of these services like roll up as a service provider, right? So there you can actually go and create a chain. It will automatically spin up RPC, spin up indexer, spin up everything, right? And then you have wallet integrations. It will also automatically, let's say, add your RPC into your wallet, which is, let's say, a white label wallet, or let's say you have trust wallet, and within the trust wallet you add this, and the user just has to enable that chain somewhere. Like, just say that, okay, I want to interact with this chain. Don't add RPC and all that. Just say that I want to interact with this chain. And wallets also, I feel that eventually, right now, the biggest problem is that none of these devices, like mobile phones and your even the laptops, they don't allow the keychain level access of the keys. But eventually I feel that all these wallets, you will be able to, the way the keychain access of your mobile, where you scan your face and then it allow you to do transactions. The end game for wallets is that, actually, where you get into the keychain level of your mobile phone or your wallet or whatever, and then you have those keys within the keychain of your main device only, right? And otherwise is like, this account abstraction and all that, where you simply create this system and that this is a particular transaction. You just scan and click OK, and you just provide a signature, and then because it's an app chain, you don't need to even have an RPC. The user interface of your application, let's say you are a game, there you just do a signature, and since it's a dedicated chain, so the developer themselves is running a dedicated chain, and they can simply relay the transaction on their chain and just put the ZK proof. So you don't even need to have gas on that chain. But then, of course, like, these indexing and all that, the developers will have to handle these indexing, which they do today also in the Web2 applications.
Yeah, I mean that's super interesting, because like there is infinite amount of things to index, and that's a massive infra that will have to be built out. That, I mean, personally, I'm very excited for it, because I feel from a dev perspective, that's the biggest problem with blockchains. You come to blockchain, you think everything is on chain. Man, the blockchain doesn't know a lot. It cannot tell me all the NFTs of my users or the tokens, and it's a lot based on indexing. So it's a massive work that will need to be done for this future of like smooth multi-chain to work. Because if you have some indexing for this chain, but not that chain, already there a bit of smoothness disappears, because what hell, I can do this on that chain, but but this chain doesn't have this support yet. So that's I feel that's a big thing that the industry will have to figure out. Sandeep, before we wrap up, let's speak a bit about different projects. Like, for example, our audience knows GameSwift because we met them in Paris, and we've been in touch, and they have been showing us what they've built. These guys are working together with you guys, and I know you tweet about them as well.
Yep.
Which other ones are interesting for our community to check this, Supernet paradigm in action,
Yes.
being created in front of our eyes?
I mean, there is huge number of them. Like recently, IDEX, which used to be the one of the famous dexes in the space, they are launching their own chain. Gnosis Pay, from the Gnosis Safe people, they are using Polygon technology to launch the Gnosis Pay chain. And there have been multiple, like Palm blockchain from Consensus. They announced that they will be using a Polygon Supernet, and plus IMX itself will probably have 100 chains, right? Because they have 150 games. Some of the topmost games in the space are building with them, and there are like multiple lined up also, like including like New Bank, which is a $40 billion bank in LATAM. They have a chain. And from that to, let's say, small games like Avegotchi and all that, all of these chains are there. And that is
how
why,
do you
like,
spell it? New Bank?
NUBANK. NUBANK. They are basically a LATAM bank, which is, I think, the last valuation was 40B or something for them. They also launched Supernet. And, I mean, there are almost like, these are some of the top of my mind, but there are almost currently 25 to 30 which are lined up, and I think by the end of this year you will see probably 40 to 50 Polygon chains or Polygon Supernets, right? And that's the main part is like also this as a part of Polygon 2.0, this Matic token is also upgrading into Pole token, right? Which is basically, it's an upgrade. It's not a new token. It's the same upgrade, same supply, everything. But then now the Pole token becomes, like, as we call it, hyper productive token, because this basically, with this, you not only can validate, like, you see that we call it third generation token. So BTC, for example, as a BTC holder, you can't stake it in the network. You can't run the network with BTC, right? But whereas with ETH, you can simply spin up a ZK or a Ethereum node on your laptop and stake your ETH and be a part of the validator network or delegate to someone. Now, but you can validate one chain. The third stage is like the Polygon kind of tokens, which we call hyperproductive tokens, wherein you not only can stake on one chain, you can stake on hundreds of these chains. And not only the hundreds of these chains, you can stake on different levels. You can stake on the chains as validator. You can join the aggregator layer to provide this combined proving, which interoperability layer, as I showed. That layer also is run by Matic Stake Validator. So they are combining the proofs and putting it on Ethereum, right? So you can join that, or you can actually, eventually we'll have a decentralized prover network. So you can join as a prover. You can run a prover for yourself in a decentralized prover network, or you can also be able to provide data availability, which we were talking about. The data availability, you want some sort of small layer where the data is with multiple parties, so nobody can do the ransom attack and all that. So you have 4 different roles minimum, and you'll have more roles also to run the chains as well as the validators on multiple chains. So all of these supernets and these chains will be secured by Pole token.
And that's important for the token holders, because I know, for example, in Cosmos ecosystem, the biggest debate is how does Cosmos capture all the value? Because they've been probably first with this app chain thesis, which, by the way, I think makes perfect sense, because as an app, you're so constrained by ETH trade-offs, because again, it's all about trade-offs. Which trade-offs do you make? You can use a general purpose blockchain like ETH, but they've made a bunch of trade-offs for you. And with app chain, you can now customize trade-offs based on your needs, and still have the same security when it's rolled into this ZK. But Sandeep, final question, maybe the most important one for this like big picture. I know that some people, including myself, we're starting to think, man, it's becoming so complex. We started with ETH. Now there is, like, on top of ETH, there is Polygon, and then on top of Polygon, there are Supernets, and on top of them, there is like another cluster. I know what you said about Immutable X, but it sounded like they're gonna have their own like cluster of chains. How do you view this complexity running away? Because there is no way like one single person can comprehend, or at least soon enough, probably already now with all of this new tech, ZK, comprehend the entire like risk profile. Because also a lot in crypto we have this, game theory. How will the network will act in its best interest, and then you have this game theory on top of game theory, compounding risk in all the layers. So is that something that concerns you? Like, how do you think about that? And then you have eigenlayer coming in, like potentially disrupting like the base consensus also with their own consensus, where you can extend consensus of ETH. How do you think about that?
Yeah. So basically, the most important part, that's why I said that you can't have these game theory. Game theory means some level of trust on a large, like whether it's a validator community and all that. The game theory is used where the mathematics cannot be used. The whole point of Polygon Z 2.0 is that if you see, it's a very flat structure. It's not something is on top of Ethereum and something is on top of Polygon. If you go back to that diagram again, everything is on top of Ethereum. All chains, even if IMX has 100 chains on top using Polygon technology, they all will be connecting back into Ethereum. So the security is one single security, which is the ZK security, everything connected to Ethereum, settled on Ethereum as a ZK security. There's no cascaded things built on top of it. Like in case of eigenlayer, that's
Makes
a separate thing because people have some Matic tokens. See, people have each staked on some other layer and then they are doing something else. That there it's a difference of layers. In case of Polygon, it's one single layer. You don't need to trust any other party. That's the main point of Polygon. But the second part is about the complexity. I feel like if I ask you what is the complexity of internet today, like anybody who wants to comprehend it, like internet, where the value information is moving, information is also can be super dangerous if you have to trust. But if you see today, when you and I are talking, all our information packets are going using this DNS service, which actually found out that, okay, this is StreamYard. And then DNS service finds out that, okay, this is the IP address. And then IP address, we have a handshake of SSL. And then once the handshake is there, after that, I'm transmitting you the data, you are receiving it, and your app layer, so there is a huge amount of complexity already on the internet also. But the good part is it doesn't need to be visible to the end users. To the end users, we are using our laptops and we simply click one button and we are there. Every complexity is being handled by this one. And this is what needs to happen for crypto. That is my large vision. And that's why I'm saying all we need to do before is with this all works in internet is because this is secured by mathematics, not some weird game theory stuff. And with ZK, that's the main part. You don't need game theory to prove computation. You just need mathematics to prove computation. The game theory, decentralization and all those is needed only for censorship resistance here or data availability. Nothing else.
I like what you said, that at the end it's quite flat because it all gets boiled down to ETH. So you have a window of this, like, this built on this and this interop layer that collects, but at the end of the day, it will just put back the proof on ETH and then you restart this until the next proof. So that's quite a good conclusion.
A very nice point. You mentioned a very nice point that if interoperable layer you don't want to trust, you want to put directly on Ethereum, you can do that. It's just that it's costly for you. But if you don't want to rely on that chain, which is actually a trustless layer, this chain is not doing any transactions. It's just combining the ZK mathematic proofs, multiple hashes into one single hash. So you don't have to trust that chain to do anything. But let's say you say that, okay, I don't want to combine my proof. I want to put it directly on Ethereum. Feel free. You just pay more gas fees and directly put it. That's why we are not building any additional layers of trust in between. It's only all mathematics.
Makes sense. Sandeep, fantastic talk, fantastic interview. Thanks for coming back on. And listen, let's keep in touch because your space is accelerating, crypto is accelerating, we're entering bull market. Let's do it again sooner this time, because last time was like a year ago. Because I'm sure that we're gonna have some explosive moves in this market in terms of everything, the prices, the technologies, adoption. We are at the brink of massive disruption. So thanks a lot for this time. Any final words to our audience?
No, not really. Only for all the Polygon community and family members watching this, just see more and more about Polygon 2.0 and what this whole vision means. Understand it more. If you have any questions, tag me on Twitter and all that, and we will respond. But I think this is the end game for Polygon, the Polygon 2.0. That this was our whole mission. I've been saying that we want Web3 to go mainstream, and till now there was no dedicated, no infra, even proposed architecture that this can be infinite scalability and bring the seamless value. And if you ask, like, I would say, if you are connected to any researchers and all that, also discuss with them all these other visions that have been proposed, super chain, this chain, that chain, hyperchain. None of them actually provides you this blueprint. And then the diagram I showed you, 80% of that tech is already built out. It's just about putting the aggregator layer, fast aggregator layer. The slow aggregator layer on Ethereum is already ready, like LXLY bridge we call
Makes
it.
sense.
So most of these technology pieces are already built out. And I think in next 3 to 6 months, maybe 1 year, we will reach a place where our tech offering will be complete. Like, okay, because we have been building for last 3-4 years multiple things and multiple upgrades, but I think it will reach a place where we can say, okay, this is the base set is already, and from there it's all traction. Yeah, so those kind of things. So yeah, I mean, this is a very exciting time for Polygon.
Check the link below, guys, and check out all the innovation that Sandeep and the team are doing. And great work, Sandeep. Great seeing all of this develop. Guys, smash the like. See you all very soon. Bye bye.